Hello, my name is Mateu Maglia, and in this presentation I'm going to talk about the numerical modeling of large deformation and soil-water structure interaction with Anura3D. After a brief general introduction to the software, I will focus on new implementations and features regarding the problem type. The software is based on material point method, and it became open source in 2021. The source files are programmed in Fortran language, and it is distributed under the GNU Lesser General Public License. To be aware of all updates related with the software, you can visit the website and also the YouTube channel and X account. The main motivation behind the development of numerical tools for modeling large deformation and soil-water structure interaction can be found in the interest to investigate several geotechnical problems like soil impact on structures, pile installation, dike, dams, landslides, flow slides, erosion, and liquefaction phenomena. The software is developed by the Anura3D NPM research community, which is an international collaboration among different universities and research groups. In particular, in the community, there is a core developer team that coordinates the development and the new releases, with weekly meetings to discuss ongoing developments and fix possible issues in the code. As said before, in 2021, the code went open source, so everybody can contribute to the development of Anura3D. As an external developer, new implemented features or improvements can eventually be included in the code once contacted the core developer team. As a user, contributions can be made by posting new applications or validations, finding bugs, or suggest developments, new features, and improvements. This is the Anura3D GitHub webpage where you can find further information such as the tutorial or the scientific manuals. In this webpage, you can download the source files of the code and the GiD problem type 2. Furthermore, a discussion panel is available to ask for questions, help, or make suggestions. The upcoming Anura3D events will be announced in this place too. Anura3D uses GiD preprocessing to create necessary text files with the input data regarding geometry, materials, loading conditions, and computational mesh. Then, the calculation phase is performed with the Anura3D standalone executable, which is generated by compiling the source code. Finally, results can be visualized with GiD post-processing or with Purview software. Let's see the new problem type used since last release in June 2023. All the options available are organized with a custom lib tool developed by GiD team to facilitate advanced customization. The data tree allows a more easy and tidy application of all conditions and options. In this simple example, we can see how it works. Let's assign the material point specification. Select the 2D single point, then the desired material and the number of material points per element. After that, we can select the desired surface and assign it. Once the assignation is finished, we can check whether or not it's successfully assigned by drawing its values. The last item in the data tree is the calculation data, where we can find all the information regarding the calculation parameters. Calculation time step data, gravity data, all this to switch on or off all the features, and finally the post-process visualization option that include the Paraview, GiD binary file format or GiD ASCII files format. After we have defined the geometry, the materials, the boundary conditions, and the calculation parameters, we can generate the mesh as usually done with GiD. After definition of geometry, boundary condition, calculation data, and mesh, the computation files can be generated. We go to Anura3D and click on Generate Anura3D files. A new folder is created in the same directory than the GiD project with the same name and A3D extension. This folder has all the material constitutive models, the Anura3D executable, the calculation batch file, the calculation parameters file, the geometric data file. If we click on the calculation batch file, the calculation starts. Once the calculation ends, we can open the results. In this case, we are opening the results with the post-process. We open the LSD generated file, and automatically all the binary files opens for all the time steps. We have seen that all the scalar tensor or vectorial results for all the time steps are loaded. Let's now select the tensor results in the first time step and the effective vertical stress. Here we can see the configuration for the initial time step for the vertical effective stresses. Let's select now the vectorial results for the first time step and the magnitude of displacements for the solid. If we click on the animation button, all the vectors results are loaded for each time steps. The last major new features in Anura3D are the construction by layers that allows the simulation of layer construction process, valid for saturated and unsaturated states, and provide the stress distribution for water pressures and displacements during construction. And the other new feature is the initialization of stresses from file that enables the import of initial conditions, stresses, and pore water pressures computed with another method, such as finite element method. The information is transferred with a text file containing the stress and pore water pressures data nodes. Thank you for your attention.